그러면서 이제 이렇게 수업 왜 안 나오냐? 잠깐. 오늘 수업은 이렇게 하자. 하면서 뭐 오늘 적분을 이런 거 배우겠다고 하면은 뭐 색깔 선택할 수 있어요. 색깔도 고르고. 그렇죠? 그러면 좀 유튜브. So you'll have a chance to review the class, and of course the PDF file will be posted on this website. It's one of the Google sites, and you know how to read your YouTube, right? So YouTube site will be under my English name. You can check David on with the title Engineering Mathematics. So there will be some, actually most of the classes for the last semester as well on YouTube, and I'm going to post after class the whole class in YouTube. It will be like 2.5 hours because it's 3-hour class. And I found out that most of the YouTube movies are very short, like 15 minutes. So that means I have to edit it, but okay, I don't have neither time nor effort. So I'm just put it the low YouTube file. So it's going to be very long, almost 2 hours. And most of you would be interested in my grade policy. So I do have only the policy only for the A plus. So there are two groups of students, group A, X, and 10%. B, student got over 90% of the total score. So there are two groups of students. It's a percent notation. So group A is a collection of students who turns out to be top 10% of the whole grade. And group B turns out to be got over 90% of total score. And A plus belongs to so in order to get A plus, you have to satisfy condition A and B. So what would be the maximum number of students who can get A plus? 10%, right? But unfortunately, if they cannot get 90%, they cannot get A plus. So we live around 10%. The last semester, about 10%. And this is the English class, so I don't have to put the relative numbers for B plus or etc. So grade will be not too harsh, but that's the policy for A plus. And what else? So no check this grade policy. Do not check attendance. Sorry. Attendance. However, there will be a surprise quizzes. Sometimes one, sometimes two, sometimes I don't know how many times. It's usually a 15-minute surprise quiz without the pre-announcement, and usually I lock the door. So when the surprise quiz starts, nobody can enter the classroom, so the door will be locked. So that's about 15 minutes, 10 to 15 minutes. The surprise quiz usually comprises about total 50 points. Around 50 points. So I have been talking about the grade policy. So to get A+, you have to satisfy these two conditions. So intersection of A and B, not the union of A, B. And normally I don't check the attendance. Some spelling errors, so I think. However, there will be a surprise quiz, 10 to 15 minutes. And most importantly, so this is the site where you can find the PDF file of the class note, and also some previous quiz problems and other things. But most importantly, I'm going to put my class on the YouTube under this name and this title. So one or 2 hour quiz every 2 or 3 weeks. So normally maybe 3 quiz or 4 quiz throughout the semester. You can safely think that we are going to have a quiz every, say, 3 weeks, sometimes every 2 weeks. So normally it takes about 1 hour to sometimes 2 hours. So you can safely think the quiz is about 1.5 hours or 1 hour. So that about 600 total points around. And we have one final, big final exam, 3 hours. That's about 300 points. So throughout the semester, the regular quiz, final, and few surprise quizzes will comprises about 950 points. But actually, surprise quiz, your percentile is regular quiz, final, over actual score plus surprise quiz. The surprise quiz is more like a bonus. So it's like 50 points. The denominator is a regular quiz plus final. So in English, this is called the denominator. 분모. And the upper part is called denominator. So actually, the denominator comprises of a regular quiz plus final, and the denominator is actually what you get plus whatever you got from surprise quiz. So actually, if you get perfect score everything, then that can be over 100%. So that's about my grade policy. Any questions? And am I loud enough? Can you hear me well? Yeah. Or am I talking too fast or too slow? It's okay? Sometimes, if you think I'm going too fast, then there is one way you can slow down the progress is asking a question. So I will give you some chance to slow down the progress. So we can discuss about the policy. So any questions about grade policy? And each quiz, yes?
Is there no midterm exam?
No. No midterm, but we are going to more frequent regular quiz. So you can think about having 3 midterms instead of 1. But I'll try to schedule the quiz to avoid the regular midterm season, so you can spend your more time to study for other subjects. The other questions? All right. Oh, my name is Doyeol. And my office is in this building, 2nd floor. And my email address is dahnus.ac.kr. So if you have any questions, you can send me an email. And if you really had a difficult time to understand the material, then maybe you can set the office hour by making an appointment with me through the email. But normally, because I'm putting on the YouTube, and if you don't understand it during the class, but you can watch it repeatedly, then I hope you understand most of the material. And your understanding will be better near the quiz time, eventually. And for each quiz, you can prepare for quiz or final. You can prepare one cheating sheet per hour. A4 size, one-sided, handwritten. So if it's a 2-hour quiz, you can prepare 2 pages of cheating sheet, and for finals, you can prepare 3 pages. So in Korean, the cheating sheet is called cunning paper, right? So officially you are allowed to do the cheating. And then you can bring dictionary. If English is not your native language, words are not familiar, you can use consult the dictionary. I prefer book form. And no engineering calculator. But no smartphone. Especially no text, no KakaoTalk, whatever So for quiz or final, you can prepare cheating sheet. That is very important. And I discovered that is probably the only time you study. So when you prepare cheating sheet, that is usually for most of you, it's the only time you study, right? And then you can prepare dictionary in the book form. No smartphone. And the handwritten cheating sheet is very important because in the past, some students use a copy machine to make a reduction, put maybe 16 pages of cheating sheet in one page. But the problem was he couldn't read. Because I also would not allow use a magnifier. No X. So magnifier is not allowed. Suppose visual. So for those students who came late, I will go back to first page. If you don't have any questions, I can continue with the topic. So first topic in this semester is going to be linear algebra. Or something with a matrix. Not the movie Matrix. So before I proceed, we have to understand why we are learning mathematics, especially engineering mathematics for engineers. So engineering mathematics, or most of the mathematics, involves with the functions. For example, fx 1 plus x over 2 minus 3x squared, etc., etc., etc. This is a simple definition of functions. Then you can see there are several operations involved. We took it for granted. Okay, you start with number 1, and then you add, right? This is called addition. X is some number which belongs to some special numbers set, but you divide by 2. So this is a division. And the third term involves this operation. You subtract, right? Addition, subtract, division, subtraction. Subtract is a verb. Finally, you multiply x 3 times, right? So this operation involves multiplication. So if you want to define some function of a variable x, then we ended up involving these 4 basic operations. It's called arithmetic operations. So 4 basic arithmetic operations. That is addition, subtraction, division, multiplication. Okay. So when you're in elementary school, in the first grade, I think we at least learned addition, right? Subtraction, maybe starting with the second grade. Multiplication, division, maybe third grade. But there's a reason why I'm telling you about, because you are familiar with these four basic operations. The question is, so f is a function, then we start with some set of numbers. And after this operation, your result is a different set of numbers, right? So, for example, f set A to set B, right? So this is a set of numbers. Set of numbers. And then if you want to define the function to get some result, then this particular set is a set of numbers, and after the operation of this 4 has to be the same set. Otherwise, function is not very well defined. For example, set of natural numbers is there's a positive integers, right? So n 1, 2, 3, etc., 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 right? So if x1, x2 belongs to n, that means x1 and x2 are natural numbers. So the positive integers. x1 plus x2. If we add them together, what happens? Still belongs to the n, right? This is tricky. If x1 is larger than x2, of course, then the result is still positive integer, so it belongs to n, right? But on the other hand, if x2 is larger or equal, when x1 and x2 are equal, then it's 0, right? It doesn't belong to n. When x2 is greater than x1, it doesn't belong to n, right? So if you want to define a function with the integer, then as natural numbers, then output can be very tricky. So you have very only limited operations. So we say the natural number is close to the addition, but not 3 other operations. Multiplication is obvious. x1, x2. If we multiply by these 2, it always belongs to the integer, right? Can you divide? Sometimes if x1 is a multiple of x2. Otherwise, it's not, right? So x1 unless x1 is a multiple of x2. So it turns out that we can safely say the natural number is close to 2, addition and multiplication. So natural numbers close to the addition and multiplication. And next number system is obviously integer. Integer is I guess I'm recording the class, right? I was hoping. Integer. So integer is minus n minus 1. Of course, there's many 0, 1, 2, infinite equals infinite. If x1 and x2 integer, then obviously x1 plus x2 is integer, right? And x1 minus x2, you don't have to worry about whether x2 is larger than or same or less than x1. It always belongs to it. And the multiplication also belongs to integer. However, x1 division is not well defined. Okay, so unless x1 is a multiple of x2 and x2 is not equal to 0. So integer is close to 3 operations. So z is closed to the multiplication, addition, and subtraction. So integer has been known for many years. That started with the invention of 0 and believed that Indian invented the number 0 around 2,000 years ago, 3,000 years ago. Maybe much longer than that. Next set of rational numbers. The rational is a ratio, adjective of ratio. So ratio, null is a adjective suffix. So Q is actually set so The rational number is called yurisu in Korean. And obviously, because it's defined as the fraction, this is the first set of number system that is belong close to the first four basic arithmetic operations. Human that are close to the basic and according to the history, the rational number system has been invented or appeared around 10th century BC, both Western and Eastern. And the reason why this number was invented was the taxation, because you need to be able to divide the land for the taxation. So you need to be able to measure, because 10th century BC is already, we started the agricultural society, and the tax is proportional to the production of wheat or rice. In the case of Western civilizations, wheat, and in the Eastern part, it's rice. So the taxes belongs to the proportional to the land size of the rice field. And you need to be able to divide the whole land by many things. And so that has been summarized by Euclid in 5 BC. And in the case of the west-eastern part is called, let me see, 구장산술, about same. Let me check the Chinese characters. Or I think. Ju is the name of the country, Ju dynasty. B is a secret. This is Sanju. Sanju is the arithmetic. So around the same time, in both the Eastern and Western cultures, appeared the mathematics books, algebra books, which can calculate the geometry and the rational numbers. So by the time they think this perfect number system, everything is perfect. So there is no numbers that cannot be expressed by rational numbers. So they believe that they have a perfect number system, perfect everything. But unfortunately, it was not. And the mathematician found that the rational number is not everything. It is a famous mathematician called Pythagoras. Pythagoras, or in Korean, Pythagoras, was asking a question, following question: if there is any number, when you square it, gives a square root 2. Because he discovered a very famous rule for the the triangular rule, right? This is 1, this is square root of 2, right? So he found the very simple rule. So he defined this new number system is called square root of 2, and then it cannot be expressed by the rational numbers. And maybe in your third year in the junior high school, you have to put that. Maybe you have done some proof. So proof is very easy, so I'm not going to repeat that. So he calls this is an irrational number. So around 2,000 years, he add with the rational numbers and irrational numbers, he put them together and called real numbers. So rational number q plus z over root 2, root 3, and even pi e irrational number sets is not close to the 4-base arithmetic operations. However, the real numbers do. So real number system is actually close to the 4 basic arithmetic operations. Two. And most of the engineering we are using real numbers. So far still real numbers, and most of the functions we are using. Am I going too fast or it's okay? 괜찮아요? So let's summarize. So and natural number systems has been known for how long? But how long do you think we have known natural systems? Very long time. Okay, my guess is maybe 100,000 before present. Integers probably 3,000 before present. Maybe 5. I don't know. Because by the time 10th century BC, the rational number system has been established quite well. And real numbers started with the Pythagoras, so maybe about 2,000 before present. So it's my guess how the natural number system evolved. There were cavemen. A long time ago, our ancestors lived in a cave. So they were hunters. So they hunt rabbits. And also there are the fishermen. They catch fish. The caveman has been eating rabbit all the time, and the fishermen eat fish all the time, right? Of course. But if you eat everything all the same thing all the time, you get bored, right? So one day, they decide to meet in the middle and then exchange one fish for one rabbit. So how they count? You use fingers, right? So one rabbit, one fish. So you can use one finger. 5 fish for 5 fingers. 1, 2, 3, 4. If you have 10 fish, you can use 2 fingers. What happens if you have more than 10? You bring your friends, right? You bring your friends, and then starting again. You can count infinitely, but there's no zero, right? So that's the reason why I think it's my guess. Our number system is based on base 10. Because we have 10 fingers. Of course, some people has 11 fingers, but it's very rare. So maybe instead of us, if the dinosaur has evolved, there was dinosaur fishermen, dinosaur hunters. Then, and so I'm a dinosaur, a velociraptor, descendant of a velociraptor between that, and you are the descendant of the dinosaur obtained in the class. Then our number system might be based on 6, because they have 3 fingers, right? So any questions? This is history class, right? So why don't you take a first break, and in the meantime you can check your attendance. So I will put it here, and then check whether your name is here. So it may take maybe 15 minutes or so. So it's going to be a very long break, and it's a good chance that your name is on the list. But that's only for students who attend today, and I don't know. It depends on their luck if you're not in the class. So why don't you start checking your name and take a break? And some student reminds me to turn on the record because previous sheet and then check if. How can I check this? Am I recording or no? Oops. So maybe I didn't record for the first hour. It happens. Or maybe not. Let me check this. Which one is which one? No, so I have to use this. So it turns out that there was no recording for that. So about 300 years ago, the Swiss mathematician named Christian Euler asked the following question. When you square some number, you get -1. Is there any such a number exist? And apparently, no real number satisfies this condition. So he defined this particular number as I, and denoted as a square root of -1. And he called this imaginary number because it exists only in in our imagine. And we can define a new set of number systems called complex numbers, which is Z is defined x plus I, y, where x and y belongs to real numbers. Then we can easily show that the set of complex numbers are also close to the 4 arithmetic operations. Let me just double check. All right. So rational number systems, real number systems, and complex number systems are close for the 4 various arithmetic operations. So we can define functions which can come to real, or rational to rational, or complex to complex. So in this way, if the number system is closed for the four basic arithmetic operations, we can define the function can be defined on the real number system, or on the rational number system, or complex number systems. Is there any other extension of these numbers? There is a possibility that it's not exactly a number, but a collection of numbers. Such as this. It's called matrix. Question. This is called question. Matrix. Matrix is a collection of numbers. So say, the question is, can we define four basic arithmetic operations? Question number 1. Question number 2, can you find some particular set of matrices which are close to the four basic arithmetic operations? Can we find a particular set of matrices which is closed to the four basic arithmetic operations? So for this new mathematical entity called matrix, which is a collection of numbers, we can ask the following two questions. First of all, can we define four basic arithmetic operations? Like, can you add matrices, or can you subtract two matrices, or you multiply two matrices, or even further, can you divide one matrix by another? If you can, that's a very big if. And if you can define the division, then can you find a particular set of matrices which is close to the four basic arithmetic operations? If that is possible, then you can even define the matrix functions. And so many modern engineering and physics actually depending on utilizing the matrices and matrix functions. So this is the reason why we are learning that. So singular is matrix, plural is matrices. So it's different from the movie. There was once upon a time there was a movie with the same title, Matrix. Let me see. The actor was a famous guy. I don't know. I'm not sure, but so for example, say 1, 2, 3, 4, 5, 6. Then this is called rows. This is called column. Column and row. The horizontal arrangement is called row, or in Korean it's called 행. And vertical arrangement of number is called column or 열. And so matrix is defined by the number of rows and number of columns. So this matrix belongs to 2 by 3. the number of rows, and this will be called shot. So from now on in my class, when I sharp means the number. So rule number 1, 2 matrices can be added or subtracted if their number rows and number of columns are the same. So that means if B is 7, 8, 9, 10, 11, 12, then they are same, it's called same dimension. Same number of rows and same number of columns are called the same dimension. So if two matrices are in the same dimension, then they can be added or subtracted. And abstractly, I can m by n is elements A, P. So we can write this way, or we can also write more A11, 12, 1n, A21, A22, A2n, AM1, AM2, AMN. B is the same, P11, P12, P1n, PM1, PMN. So assuming that A and B are of the same dimension, so same number of rows and same number of columns, and then we can write down the matrix by its elements Aij or Bij, or we can write explicitly by each component. Then addition or subtraction is defined by addition or subtraction of each component. So let's do some simple example. Maybe it's a bit over too abstract, but so let's do some simple cases. So say A is 1, 2, 3, 4, 5, 6. B is 7, 8, 9, 10, 11, 12. So the matrix addition is to just add each component. So A plus B is easy. You just add. So 1 plus 7 is 8, right? 2 plus 8 is 10. 3 plus 9 is 12. 10 plus 4 is 14. 16, 18. A minus B is same. 1 minus 7 minus 6. 2 minus 8 minus 6. 3 minus 9 minus 6. 4 minus 10?
minus 6.
5 minus 11?
minus 6.
6 minus 12?
minus 6.
Strange. I didn't intend to do that. Maybe we can do it. So that's 3 by 2 cases, right? Maybe we can do some simple case. A 1, 2, 3, 4. It is 2 by 2. B 5, 6, 7, 8. One more. A plus B. 6, 8, 10, 12, right? A minus B minus 4 minus 4 minus 4. Strange. The multiplication is a bit tricky. If A is M by N matrix, P is a P by Q matrix, then in order to define AB can be defined if N is equal to P. On the other hand, BA can be defined if Q is M. So that's important. So AB, say AB, M by N, N by Q. IJ component is sum over K equal to 1 to N, AIK, BKJ. It's not a good expression. So that's this means IJ component AB. So this is you choose the element from the ith row, and you choose the element from J's column of B, and then multiply each component. Okay. So choose ith column of A. Row of A and J's column of B. Still looks like I'm a little bit going fast. So anybody who has taken, who had learned how to multiply two matrices in high school, raise your hand. 수학의 정석에 있죠, right? Okay, so let's do some example. Multiplication is tricky, so I like this particular set. 1, 2, 3, 4, 5, 6. So this matrix belongs to 2 by 3 class. So if we want to multiply by B, And maybe B has to start with 3 rows, right? So let's start with B. 7, 8, 9, 10, 11, 12. So this is a 3 by 2 matrix. So AB so first element is from this. So you choose the first row and first column and you multiply each component and add. So this is 7 plus 18, so 25 plus 33, 58. So 7 plus 18 plus 33 is 58, right? And you should be able to do by just memory. Now second component, 1 times A, 2 times 20, 36, 56, 64. Correct? 8 plus 20 plus 36, 64. So that's the component value of matrix. Oh, it's getting harder. The second row, first column is this here. So 4 times 7, 28, plus 5 times 9, 45, plus 28, 45 plus 28, 73, plus 66. 73 plus 66 is 179. Let me check. So 28 plus 45 plus 66, 139. This is 3, 7, 139. Okay, so my memory is okay. Last one. Okay, 4, 8, 32. 50, 88, 72, 88, 160. Let me check. 32 plus 50 plus 72, 82. Sorry, 154. Okay, so I was wrong. So it looks like why you need the calculator for kids. And this is a lucky choice because we can actually multiply by B by A. It's a 2 by 3, 3 by 2, 2 by 3. So we can actually multiply by A, B, A. And I forgot. I don't want to do it again, so let's try. Oops. Oh, this one. I can make a copy. Oh, no. Edit, copy, and then okay, throw it away. And next page, calculation AB was 2 by 2. B, right? This is 2 by 2 matrix. Even dimension is different. inspector, paste, paste, paste. I think this. Great. I can. And let's try PA. So B is 3 by 2. So we have to do it the opposite way. So the first row, first column, seven times 1 plus 8 times 4, 7 plus 32, 39. So 7 plus 32, 39. And second row, 7 times 2, 14, plus 8 times 5, 40, so 54. But I'm going to write 7 times 2 plus 8 times 5 is 54. And the final column, this. Seven times 3 is 21. 8 times 6 is 48. So 69. Let me check. 7 times 3 plus 8 times 6. 21 plus 48, 69. Okay. 6 more. So we have done 3. Okay. Second row. The second row, first column. 9 times 1 is 1. 9 plus 40. So the start is easy. 49. 9 times 1 plus 10 times 4, 49. Second row, second two component. This, right? So 9 times 18. 2 is 18. Plus 10 times 5 is 50. 68. So this is 9 times 2 plus 10 times 5, 68. Finally, 3 components. 3 times 9, 27. Plus 6 times 10 is 60. So 87. So 27, 3 times 9 plus 6 times 10, 87. Finally, third row, first column. 11 times 1 is 11. 12 times 4 is 48. So 48 plus 11 is 59. So 11 times 4 plus 1 plus 12 times 4, 48. 48 plus 1 is what? 59, right? Last two. You have been very patient. So we are getting there. 11 times 2 is 22. 5 times 12 is 60, so 82. 11 times 2 plus 5 times 12 is 60. 82, right? Final 11 times 3 is 36, plus 6 times 12, 72, 36, 105. 11 times 3 plus 6 times 12, 72 plus 3 is 105. Oh. So this is a matrix. So BA 39, 54, 69, 49, 68, 87, 59, 82, 105. If you go back to the previous class, this matrix is 3 by 3. So in general, so if the matrix multiplication is up, even if you find, if you change the order, the result can be different matrix. In actual number system, it's always the same, right? 6 times 3 is 18, 3 times 6 is 18. So no matter how you dispose the two numbers, change the order of the numbers, the result is the same. But in case of the matrix, if you change the order of the multiplication, it's different. And so this property is called non-commutative. So when AB is different from BA, we call this non-commutative. Or mathematicians like to invent exotic word, so it's called abelian. The same word. So this can be a good practice. Maybe I can go back. Just a little time. So let's say (17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So this is your homework. And so my homework is you work at your home, okay? But you don't have to sum it. You don't have to give it to me. I don't want to check. So homework is homework, just at your home, and do not sum it. Because usually I found that when I give a homework and collect them, maybe 20% of the students do the homework, actual homework. The other 80 is copy. So it doesn't make any sense. It's wasting my time to grade all the homework. So just at your home. And this 4x4 multiplication will take how much time did it take for me to do that? About 10 minutes, 20 minutes, right? So I think 4 by 4 need maybe 20 minutes. So this is 4, so 80 minutes. So best time to do at homework is you are a sophomore, right? So you do a lot of blind date, 소개팅. So when you go out, waiting at the coffee table, waiting for your blind date to show up. So, but he or she may never show up, right? This is for the student. And so maybe normally you wait 1 hour and then go if he or she doesn't appear, right? So during the time you're waiting for your partner, it's homework. So you can easily spend 1 hour and then you can get a good grade too, right? Because so this is the basic start of a matrix computation. You need how to multiply these two matrices. So 4 by 4 is a good start. And maybe you can take a break for 5 minutes and continue. Those classes until 2, so we still have enough time. So we'll take a 5 minutes break and I have to repeat it again. So when we have a matrix which is given by n, then means the number of rows are the same as number of columns. It's called the square matrix. And that is the case when actually the matrices are close to the 4 basic arithmetic equations. So we are going to consider the square matrix from now on. And unless otherwise specified, I will focus on the square matrix and also mostly 2 by 2. So say A, 1, 2, 3, 4. B, 5, 6, 7, 8. C, 9, 10, 11, 12. Assuming that we are going to multiply 3 matrices together, then there are 2 possible ways. We multiply A, B first, and then multiply by C, right? Or we multiply by B, C first, and then multiply by A. That's what we do when we multiply 3 numbers, right? So in the case of actual numbers, the multiplication of 3 numbers doesn't depend on the order. So for example, 2 by 3 by 6, you can multiply by this. This is 18, 2 is 32, right? Or you can multiply by 2, 3 times 6, 36. So same. This is a very important property. So when you multiply 3 matrices, the order of which matrices are multiplied first is not important. I mean, numbers are not important. It's called associative rule. 결합 법칙. So question is the same 결합 법칙 or associative rule will hold for the matrix? So this is my question. And we are going to see that. Give you time to copy. And while you are making a copy, maybe I can take a full picture of my class, so I can maybe cover for the YouTube class. So look at me, smile. Nice. But I have to learn how to put as a cover page for YouTube class, so it may take some time. So for now, until I learn that, it's going to, maybe I can put as a copy and paste into one of the pages. So let me see. So I remember. So AB 1, 2, 3, 4 is 5, 6, 7, 8. C is 9, 10, 11, 12. So let's try this ABC. So AB 1, 2, 3, 4, 5, 6, 7, 8. So now you should be able to do that by memory. 1 times 5, 2 times 14 is 14 plus 5, 19. One times 6, 2 times 8, 16, 24. This bit tricky. 15 plus 28, 43. 15. 1, 5 plus 28, 43, right? And 18 plus 32, 50. Oh, so ABC. Yeah? This? 22? Let me check. Okay. Oh, 6. Thank you. I could make a big mistake. So I must be getting old. 50 times, 9, 10, 11, 12. So it's going to be a real challenge without. Let's try first. My mind. 171, right? So 171 plus 22 by 11, 142. So you need a calculator. 22, no, 242. I'm really getting old, or maybe I'm hungry. So 242, 171 is 3, 1, 4. So 4, 1, 3. Very good. 4, 1, 3. Okay. I hope. Sorry. This. 190 plus 22 times 12. 264. 4, 5, 4. Correct? You need to double check. I could make a mistake very easily. Oh, this is really hard. So 7, 387 plus 550. 7, 3, 9. Correct? Okay, last one. This is easy. 430 plus 600. So it's 1030. So we need to remember this, A, B, C. A, B, C is 413, 454, 937, 1030. Now, BC. Four and three. So first component agrees, right? Next one is 5, 4, 5, 4. Let's check second term. 5, 4, 5. And 9, 3, 7. Remember 9, 9, 3, 7. 1030, I think. C 5, 6, 7, 8, 9, 10, 11, 12, right? So we calculate the BC first. The first one, 45 plus 66, right? 45, 66, so 1, 1, 1. Good number. It's 50 plus 72, 122. Now it's easy. Okay, 7, 9, 63 plus 88, right? So 1, 1, 5. 1, 5, 1, correct? Last, 70 plus 96. So 166. So now we can A, B, C. 1, 2, 3, 4. 1, 1, 1, 1, 2, 2, 1, 5, 1, 1, 6, 6. Okay, so so the first term is 1, 1, 1 plus 302, right? So this is 4, 1, 3. And let's check. So let's check this with this. 1, 2, 2 plus 2, 3, 3, 2, right? Is 4, 5, 4. And 1, 2, let's go back. 7. So let's try check this. 3, 3, 3. 604. 9, 3, 7. Right? Same. Finally, final number was 3, 3, 66, 161 use. Six, 4, 10, 3, 10, 30. Oh. So through the example that A, B, C, A, B, C. So even though the matrix multiplication is not commutative, it's still associative. That's one very important discovery. So multiplication is associative. And maybe I can give another homework. 4 by 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. B. I make your life easy for you. 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. C. However, 17, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So check. This is homework. So do it at home, but you do not turn in. This is actually quite a vicious homework because I think this multiplication will take a long time. Maybe you have to wait another 2 hours although you're waiting. But actually, abstractly, it's easy to prove. Associative rule. But I will. This is a good example. It's actually, it will help your memory. 힘의 예방이 좋아요, right? So you can prevent Alzheimer's disease if you keep practicing, multiply numbers, many numbers, add them together, multiply together, and possibly using your just memory will be good for your memory. Abstractly, I don't like red, so maybe use this. It's A, B, C, or n by n matrix. So we can define Aij, Bij, Cij. So A, B, Ij component is defined by k is equal to 1 to n Aik Bkj, right? So if we want to multiply ABC, Ij component, we just need to compare by component. It will be k equal to 1 to n AB Ik Ckj. And again, this is k equal to 1, L equal to 1 to n AIL BLK CKJ. On the other hand, so that's your result. The proof is very easy. Abstract way, That's your component. AIL, BLK, CKJ. That's actual component. On the other hand, sum over K, sum over L. Can I move on to the next page? AIL, BLK, CKJ. Same, right? So component by component is the same. So that's a very simple proof. So A, B, C, IJ component can be looked this way. M equal to 1 to N, AIL, BC, LJ component. And equal 1 to N, BLK, CKJ. So we can combine them together. AIL, BLK, CKJ. That's your expression. And so just remember this order. Sum over L, sum over K, IL, LK, KJ. Right? If you go back to the previous page, so we can safely say A, B, C, component is the same. So each component, if each component are the same, then matrix itself can be considered the same, right? So from this, we can safely say A, B, C, A, B, C. So you just need to show this associative rule for 2 pages for abstract component. But unfortunately, my homework is for the actual numbers. So you have to actually calculate all the numbers, add them together, multiply another matrix, and show final result. Yes, you have to show finally that each component is the same. So that's a good practice for you. So associative rule is really important, and it's also very important rule to show the divisibility of the matrices. We are going to transpose. Transpose is that you change rows with columns. So for example, it's called T. A 1, 2, 3, 4. Transpose. You change column by row, so this column becomes row. This column becomes second row. Or when A is Aij, the transpose of Ij is Aji. So you change the column by rows. It's transpose. It's a combination of 2 words. It's actually Latin. trans is means across. Pose is form. So when you say take a pose for the picture, say something like that, right? Transpose, you change. So trans is across. So transcontinental. Across the continent. Trans-Pacific. Across the Pacific Ocean. Trans-Atlantic. Across the Atlantic Ocean. So this translating prefix is called prefix. 접두사. Prefix. So if you put trans something, then it's close. So you need 4 additional words for TOEIC instead of in addition to the math. Another interesting thing is like A, B transpose is B transpose A transpose. So maybe it's today, first day, maybe shall we stop? You must be hungry. Okay, so I'll be stopping a little early today. We still have 20 more minutes to go, but so any questions so far today, class? So we will continue next week on the transport things. And do your homework. Okay.